thanks for this. My name is Tony Danev. I'm from SVA International. We were the architects on this project. And joining us is also Keshin and his team, who were they were the steel suppliers, fabricators, and installers on site. So they were specific to that scope on the contractor end. So I'll speak in particular to the project, to the design concept and execution. And then towards the applicable slides, I'm going to hand over to Keshin and the team in relation to manufacturing, fabrication, quality control, etc. The project we have nominated is 274 Kaliedoscope. It's a new office park development in PE, in Port Elizabeth, for one of our clients. And it has a number of corporate tenants, one of them being the new APSA regional branch, which we were involved in. So I'll just go through how the project came about and what it entails. So the client approached us. They own a piece of land. There was an existing building, which was an office complex as such. And they were looking to renovate, do an addition, etc. So on the image on the left, we can see what the building or the complex looked like at the beginning before we got involved. And on the right-hand side, I've indicated more or less where the various interventions are. So one of the existing buildings, we introduced a new steel roof structure, which I'll speak to about later. There's the red outline, and the yellow outlines is the new additions. So there's a new building on the bottom, which is the long rectangle. That's where the new extension part was. And then there was a new sort of intervention on the corner of the building, top right. In essence, this is just a very basic site plan, which indicates how the various structures came about in terms of scale and relation to the parking area. There were a number of existing properties which got amalgamated into one for the requirements around parking, etc. So the new portion, the new building, is the bottom blue outline, and the existing was the orange. And part of the existing was also, obviously, as I mentioned, there was a new steel structure brought into that. The next slides show some of the initial concepts of how we envisaged this to obviously materialize this building. As I mentioned, the tenant mix was a number of corporates, some of the bigger companies, and we were looking to create a new contemporary aesthetic, something that really positions this building and really positions this office complex, in town, and gives a very particular, face to not just the client but also to the immediate precincts. The building is located on a very prominent road in town. There's a great amount of visibility, traffic every day. So it was something that we were given the opportunity to really think about how this to come about, and I'll speak about it later on. So these were the initial concepts. Some project information. I think it's mostly self-explanatory, but the total project cost was just over 100 million. And there were various structural components, steel girders in relation to the roof, but also some tubular components, which I'll speak about later. And in terms of where the building positions itself, it's a commercial office. As a development. Lizel, I'm not going to read through all of that. I think in terms of the design concept, we spoke about the aesthetic part, but maybe one thing I can mention in relation to obviously the use of steel specifically is we had a very, very tight project deadline in terms of how some of the tenants were secured. Obviously, one of the main anchor tenants was the APSA regional offices, which I'll speak to about later in the presentation. So once the lease was secured and finalized, they had a very compressed timeline to move out of their current premises and move to the new premises. So obviously the new building we are talking about today had to be completed in a very short period of time. And I'll show some images later with specific reference to dates. And I think the only reason why we could achieve that was obviously through the use of steel and how we conceptualized the upper floor structure and the roof. And without that, I think would have been, or at least to my experience, would have been impossible. And that essentially would have been no project. At the end of the day, a lot of these commercial developments, especially when it comes to, the financial risk, the expectations from the banks in terms of financing, if you cannot make it work within those timeframes, there's no project, and the tenant walks away and looks for another premises, or the landlord looks at another building. So this sort of came about. It was quite a while in the making, and then it sort of the discussions became with the various tenants sort of became very. They finalized very quickly, and the project had to happen very quickly. So there was a decision made as a team, as a professional team with all of us, that this could work, but we have to work together, and we have to engage the right people, the right contractors, the right suppliers, and obviously conceptualize the building as not only as architecture, but also as a structural system in a particular way, which then could make those deadlines work. So then we had a project on our hands, and I'll speak about how the various components work. And so that's in particular to the building, but also we were involved with the tenant fit out on the APSA corporate offices side, and I'll show some details later on. Just in terms of some technical information, there were about 60 tons of steel used throughout the project, various profiles, as I'll show later. And there was obviously the roof cladding itself, the roof sheeting. There's some numbers there. We used one of the Sofintra sealed fixed products, the Saflock 410. It's a very popular profile and very versatile. So in this instance, that's what worked around the roofing. This is some details in relation to some of the technical team on the structural side. The building was conceptualized as I suppose a hybrid structure, if you want to call it that. There was obviously reinforced concrete on ground floor, but the upper floors, it's a steel structure which supports a lightweight steel roof. Obviously, speed of erection, versatility on site, and also gives a particular aesthetic. It's a much lighter roof visually, so there's a canopy. So all these decisions to essentially put this building up in such a short space of time, by extension, inform the aesthetic of a large overhang canopy, etc. So this is some images in relation to that, specific details to the roof, how that came about, and the ideas of how to make this happen within the budgets and within the timeframes. I mentioned one of the existing roofs had to be essentially removed and reintroduced. The height was too low, so the building on the left-hand side, there was an existing roof in that area which didn't meet the tenant requirements, so we had to lift it. So the existing roof was removed, a new roof was installed, again in minimal timeframes to minimize disruptions to existing tenants in the building, and obviously manage that. Some images during construction. You can see the new build on the right-hand side, how that came about, and the existing building on the top right. And again, some sort of images from the top. Obviously, the use of steel allows for a lot less sort of interruptions on site, while other trades can continue, how the roof structure is put up, the various support elements. Again, all these decisions ultimately informed how the building evolved as a piece of architecture and such. You can see the new roof on the right-hand side on top of the existing building. Then obviously the new extension bottom along that, some structural details. Obviously there were a number of bespoke decisions around how the roof supports, especially the existing building. Some of the carport details, the steel posts. Obviously there were opportunities to really articulate some of these elements as they were going to be exposed. I always think the structure should be exposed wherever possible to tell its own story, how the loading works, how the loads are transferred. It also creates a very particular aesthetic internally. Obviously, the steel supports, on average, smaller in scale and proportion than say, a concrete support for that matter. It's a bit more elegant. It's a bit more sort of as a fine detail. In terms of the BIM modeling, obviously, we work in a BIM environment as architects, as engineers, and obviously Keshen and his team did all the modeling in their 3D software, proprietary software, which results in a tremendous amount of detail, which we then directly link into our models, into our sort of 3D software, minimizing sort of errors and misalignments, and service coordination becomes so much easier. These are various images taken directly from our 3D software. And a lot of these structural components that you see, they're directly provided by the supplier, by Utenex Super Steel and their detailers, and they are sort of modeled to a very high level of accuracy in terms of how the connections work, which we then link into our models, and are able to resolve other details in terms of, say, the rest of particular junctions and connections, of how, let's say, the roof cladding works or some of the shop fronts. And because the information is of such high level of accuracy and detail, it makes everyone's life much easier and eliminates sort of the issues of service coordination, something not lining up. We've done a few projects with Utenex Super Steel, obviously through the main contractor, and we find this level of workflow, it's highly valuable for all team members. And ultimately, the client receives a better product, and the contractor can build from a more informed base of information. So this obviously was a critical part of the construction process and the workflow from our side. In terms of the roofing, I mentioned we used the Sphintra product, which was the Sapler 410. The roof was essentially a very slight pitched sort of conventional hip roof on either side, with a concealed gutter on the edges. From the bottom, we developed a particular flashing detail, which visually makes the roof very thin and gives the notion of a floating canopy. So the overhangs are slightly exaggerated for a number of reasons. For driving rain, in our region we receive a lot of driving rain, especially in winter. Protects in summer for overhang, for sun glare, etc. So that was the concept around the roof. This is a very short video I'm just going to play throughout the construction process. I hope it's visible. You can see some of the steel canopies. So maybe very briefly on those, they received solar panels, and one of the requirements from the client was to not have supports on the ends of that. Obviously, people tend to drive into those and bump them, so they're supported on a single post from the island, and sort of brace from the top down. I hope we're good for time. Liesl, just let us know. I'll just show this is sort of what the site looked like on a typical day, and how the building came about. You can see the existing building receiving a new roof, and obviously the new extension at the bottom. This is quite a prominent arterial at the top, and the building's positioned in a very prominent corner. So all these things were taken into consideration.
Sam, I think the important thing is that the attenuation.
In terms of fabrication, I'm going to hand over to Keshen and the team, and maybe they can just take us through some of their workflow. So Keshen, over to you.
So, thank you so much for handing over to us and giving us the privilege today of presenting with you from Utenex Super Steel side. We just say thank you for the opportunity. So today we're presenting the Absa Boricom building. As you can see, this is the image that we stole from SVA's website. It's a beautiful image of the building. And yeah, Tony is quite correct. This is the main road of Port Elizabeth, Cape Road. So it's quite an eye-catcher when you go past, and we do get a lot of compliments for it. So well done. So, Patrick, you're going to talk about the first part of the presentation.
So as Tony mentioned, the scope was to obviously replace the first phase was to replace the existing roof. So just to briefly go through here, for us the project was ABSA. The total tonnage was 60 tons. The finish, it was a painted structure. Mandarin Tusk and Mines Grey was the color. The scope included for us was the fabrication and assembly of the structural steel columns. There was a staircase in the front of the building as well. Just want to go on here. So, yeah, as Tony mentioned, we receive architects and engineers' drawings, to which we scrutinize. We use Tekla to build up an IFC model and do our shop drawings, to which, and then as we're building up the model, we issue for approval to liaise, to sort of overlay with the engineer and the architect to go through any comments and have a review period to make sure everything is fine and get approval on that. Once all the how can I say, the approval process is completed, we then move on to the shop drawings, where we now move on to issuing the shop drawings, making sure that the lengths are correct in terms of galvanizing lengths, sandblasting machine, material lengths when we source the material. And so I don't know what much to add onto that.
No, nothing much. That's the drawing process.
Yeah.
So yeah, when it comes to the manufacturing capability, Youthnik Super Steel, we have all our equipment in-house, which helps us control the flow and the speed of the project, and also giving us the best quality product at the end of the day. So I've got an example of our plate processor. This is the biggest plate processor in the Eastern Cape, 30 meters long. We have our saws, we have our drills. So at Youthnik Super Steel, we don't mark out and drill any holes or cope or miters in. Everything's automated for the best finish to the customer. So we also TUV approved when it comes to controlling our quality products and dimensional accuracy. So yeah, that's a big plus for us with our in-house quality team. We're sure to drive the project and meet scheduled deadlines. So this is some examples of the Vodacom ABSA building during the manufacturing process. We have some ties, we have some trusses, we have some major plate brackets. Most of the trusses had hip connections, so the accuracy of that has to be 100%, because Jan Hendrik will explain later the crane constraints and the height restrictions. So if you lift and you're joining a hip, everything has to go in on the same day. There's no forgiveness there. And yeah, luckily enough, everything was well controlled and well managed, and everything went in first time. Some more examples of boilermakers, and there's the kind of examples I'm talking about: massive hip connections, controlling the weld, controlling the heat to ensure that the cords don't distort, they stay straight, the handling and the controlling of the crane processes, ensure no damages or bending of the steel, controlled by all different managers. We have from startup, we have parts and fit-ups, we have a manager, then we have your fabrication operations guide, and we have our own quality. Then even our welding manager comes into play to ensure that everything's done in accordance to AWSD 1.1, and we don't miss a weld. And then we have obviously quality control, in-house paint system, which I'll show you now. So yeah, we had some curves and we had some radiuses at the beginning of the project, which went very well. Concrete was done quite well, so that made our job easy and successful. And then obviously quality control and welding standards, material traceability maintained throughout the fabrication process, welding procedures executed to approved WPS specifications, as I've mentioned, AWSD 1.1, visual inspection and dimensional verification completed during assembly, Also, we control our steel through a Zinto tracking system, so we don't lose items. You see the little tags here. So every time it goes through a department, your item has now been flagged and it's moving on. Workshop production assembly, we have efficient fabrication sequencing, improved production turnaround time, heavy steel trusses assembled with control fit-up procedures, meaning that nothing will be built unless the jig is signed off. If we have 10 jigs, all 10 jigs get signed off, so it's 100% checks on quality control. Use of workshop jigs and equipment to maintain alignment, that's the most important thing. Especially when you're working with circular hollow sections, it's not very forgiving. If you get your bevels wrong, you're going to waste material. So coordination between detailing, fabrication, and site teams ensured the successful delivery of the project. When it comes to protective coating, customer property, we take pride in that. We have a state-of-the-art paint shop. Everything is controlled in an environment where we check the humidity levels 3 times a day to ensure that when we're painting, we have the right temperatures. We do not grind our steel. Everything goes through a wheelabrator. So you're getting practically new steel at the end of the day. It's a very costly process, but it gives the client the best result in terms of longevity and guarantees on his paint system. As you can see, we take pride in our quality of paint. When it comes to customer property, as I said before, the tagging and scanning system. To ensure the project is successful, we need to ensure the right parts are there at the right time. So we have our own in-house logistics team and truck facilities. So we control the flow of work at the pace it is required to be done. And then I'll hand over to Jan Hendrik, who will talk about the erecting of the structure. Thank you from my side.
Good morning. So it's a very interesting structure in terms of logistics and all the things. So the most challenging part of the installation was obviously the amount of structural steel and concrete connections, which is most of the time the very challenging aspect of structural steel, because concrete is always straight and steel is always skew. So we had interesting sections where Keshan and Antonia has spoken about. We had hip trusses on this building where we had trusses going into corners. Later on, you'll see a photo of the brackets we had to make to accommodate the trusses that goes into the corners. So the challenges we had, we knew we had to do a lot of planning ahead of time. So we did multiple surveying where we actually now started doing on basically all projects where we'll do a survey of the building or the concretes, and we'll do an overlay on that onto our design to see if there is going to be any hiccups or errors of concern before we even start with the installation, because it's always cheaper to do it beforehand than to have all plant and workers and guys on site and then catch the problem when you're there. So I would definitely say that the biggest challenge on this project was just tying up with the concrete, as there were a lot of aluminium and windows incorporated in the steel, going from steel to the concrete. So that was where I would say that would be the biggest challenge on this project. The next one is just showing you the logistics. You'll see in the bottom is an active road, and then you'll see the top is an active parking lot. So we were really pushed for space. Getting work. You can see there my crane is sitting right up against the hoarding. So logistics wise it was challenging, but I mean with proper planning we were able to do it successfully between the different contractors on site. So that was just a matter of planning it quite good. So there you'll see just saying that there's limited access on certain sections of the road. But with the planning that we did with all the contractors, we sorted that out. That's just a photo. I think Tony also shared this. So you can see on this, one of the challenges also was we had a lot of lines on this project where there were the facades in the front section that was basically built off our steel. So our lines on this building had to be very close to 100%. So that we don't have crinkles in the facades or on the flashings. So that was quite challenging, once again, taking steel to concrete and making sure that you get your lines 100% right. Sequencing and crane access, we've discussed this. There was a lot of discussions on sequencing, getting into certain areas to get out, to get the second trades in. So that was all just sitting on site, going through it multiple times, discussing areas for the crane to stand so that everybody can still go on with their building, and brickies and everybody. So yeah, it was just a lot of correspondence and meetings and planning to get to a successful project at the end of the project. As you can see, yeah, it's got multiple lines on the hips. They're getting the central line and the hip lines, and then you've got the gutters on the outside. So there was a lot of lines that had to be kept straight on this project, which was challenging, but we did achieve it. So yeah, happy with that. And then there were changes on the project, but like I said, yeah, it was no massive changes on main building. It was smaller sections just tying into the main structure. So like I said, because we put it up the first time, tying in is not that difficult because things are where they're supposed to be. So that's matter smooth. That's just a section showing where the hips go into the corners of the concrete to see the complexity of it. Lining up. So yeah, it's always a challenge to get that right first time. So yeah, it was a well-oiled machine. That's from our side.
That's the project achievements. We demonstrate high-quality steel manufacturing capability, delivered structural accurate fabricated truss assemblies, maintained strong safety and production performance. I know Hendrik spoke about it was a site that did not stop work at the site between so a lot of planning about people, where you're working, where we're lifting steel, what times, lunchtime, and yeah, it wasn't your normal project where you could just go in, put up steel and move out. A lot of careful coordination, and of course there were a few words exchanged when the wind came up to add more frustration, but we got it done, and then well done to the team. So yeah, we showcase local South African steel fabrication expertise. Thank you.
Yeah, I mean, maybe just very briefly, you see what happens. Sometimes things don't align on site. Obviously, this was concrete. It would have been a lot more difficult to resolve, but we still, you can make a plan. But this is the realities. It is the realities of the site. And obviously, when you have a great team and expertise, it becomes so much easier. In terms of the benefits of steel, over and above what we've mentioned and what Cashin and the team have mentioned, obviously the speed of erection, but also the opportunities from an architectural alignment. The steel roof is supported on a set of tubular columns, which we offset from the outside walls in. For a number of reasons, it allows for the exterior walls to be dependent and gives us more flexibility in terms of the aesthetic and the modular expression, and also allows for the introduction of a high level of windows just below the roof line. So you can see there's a detail which developed at the bottom right, where the end of the trusses is stepped up and out because that portion of the eaves is not load bearing, and we can then introduce a high level window which brings natural light, especially for an office environment. You can see the bottom right, and it appears to be floating, especially when you're experiencing the space internally. So these are the little details which then come about from the use of steel due to its flexibility. Then this is now the expression of the facade externally.
No, I think
because these walls are essentially freestanding, they're not supporting the roof. It allows for multiple opportunities for a pattern that evolves, and in this instance, obviously that was that. This is the back facade, same principle. You can see the high-level windows. It's a very contemporary way of, we thought, dealing with that in terms of the expression of the building. Just in terms of timing sequence, this is what the site looked like in February last year. That's in July. So you can see how, obviously, everything we've spoken about made this possible. This is in August, a month later. Over and above this was existing working offices on the left and all the challenges around that. That's in November. So sorry, that's where we started in November 24, before there was anything done on site, and that's a year later, November 25. Essentially 12 months down the line. I'm not going to go into quality control. I mean, this is self-explanatory. Utenex Super Steel mentioned a lot of that. Yeah, this is how tight it was in terms of, you know, and in what we've achieved over and above the previous comments. Obviously, we first of all, we managed to achieve the client's objectives to have the building ready in time for all the tenants, and we created a office park or a new office precinct, which is in line with what we aim to achieve from a contemporary aesthetic point of view, and obviously in terms of the tenant specifications. This is some of the images of the completed building. I'll just go through some of these very briefly. They can be obviously looked at one's own pace. And of course, as I mentioned, we were involved with one of the tenant fit outs for APSA for the new regional offices. These are some of the interior images, and you can see how we left the steel support columns, the round columns, exposed for that particular reason, and it creates a very particular aesthetic. Some of the images. So obviously it's an open plan office scenario in most instances. And of course, with a lightweight steel roof, this is fairly easily achievable. That's quite a wide space. It's way over 20 meters. You can see some of the steel supports, and that's all that's carrying the roof. It's a 150 diameter column at every 6 meters or so. And then the other column is a good 20 meters on the other side. Because it's a girded truss, it can carry all that on its own. Gives us flexibility spatially to manipulate the space, the planning to great degree, and we feel it results in a very particular aesthetic. Some of the other images around the actual office fit out. Here you can see again the steel columns and how the edge of those high level windows, when you're inside, it makes the roof appear so much more lightweight. Some of the meeting spaces. This is the entrance foyer of the new building. And again, some images from the outside. And maybe very briefly, that's where we started. That's where we ended up. There was obviously a new addition to the corner, etc. So there's a very brief video. I hope there's a few minutes left to watch that. Just to give everybody an idea of what the building looks like now after everything that's said and done. This is the last slide in the last video. I'll just play it very briefly. There's also particular landscaping along the building edges. It gives the users the opportunity, when you look out of your office window upstairs, you see greenery. It gives a very particular, it softens the edge of the building quite substantially. Here you can see a bit more context of how prominent this location is. So maybe just in closing, while we have a few seconds, and this is the last slide. Yes, it is. The benefits of steel in this particular instance, there would not have been a project because of the timeframes if we couldn't develop the structural system the way we did and have the right capabilities from a technical point of view, from the installation team and the manufacturing team to pull it off. And of course, then the architectural language which evolved as a result of that to give the client what essentially they were looking for initially. So thank you for this. If there's any questions, I'm happy to try and answer those. Thanks, Liesel.